Welcome back, OChem 1. So excited. Okay, now if you're watching your Unit 4 videos, you need to watch the HBr DCM video before this one. This one comes after. We're going to use what we learned in the HBr DCM video on this one. So we kind of talked about alkenes and how they would make good nucleophiles in the last video. So we're just going to build on it. We're going to do the exact same thing in this video. In fact, we're starting from the same alkene, propene, and we're even using the same HBr. So we already know what our first step is. We already know what we're going to do for sure. What is the one thing that we've changed? Our solvent. I wonder what that's going to do. It's like a cliffhanger. That needs a sparkle pen. All right, so we already know right away that we've got available electrons, this nice pair right out there and available, right on our alkene, and we've got a really strong acid. So we can even start our mechanism without even talking about our solvent changes yet. We already know the first step in our mechanism. Those electrons, what did I do? Those electrons right here are going to be our nucleophile, and then we're going to react with our strong acid, HBr. Same first step as the previous video. All right, same process. Anytime our alkene is a nucleophile, we are going to swing both ways. So as soon as we do this, I like to label my choices. We've got two possible choices here. We get to swing both ways. So we can swing out this way. Let's do that one first. Okay, and then that means that we're swinging out here to form that bond to hydrogen. And then what do we leave behind on the other carbon of our alkene? Carbocation. Okay, I love it. All right, let's do the other one. What if we decide to swing the other way? Now we've got our alkene. We're going to swing up here to form that bond to hydrogen, and then leave a carbocation right there. All right, out of both of these choices, this is not a place where you just memorize where stuff ends up. And if you are taking your organic chemistry from somebody who is coming out of the 70s or 80s and you had your little flashcards, that's exactly what you would do. There's no point in memorizing this. You already have the tools in your tool chest. Which one of these choices is the better one? The secondary carbocation or the primary carbocation? Absolutely the secondary carbocation. In fact, that's the one that's going to win. Now for my MCAT takers and sometimes my organic people that might take organic 2 at another college, this is sometimes called Markovnikov addition. Again, I'm not into memorizing, you know that. You have a cheat sheet. Well, now I guess the world's your oyster, right? Now that we're online. So you don't have to memorize Markovnikov addition. You just need to look at your carbocation. Which one's the better one? Well, the better one is definitely this top one. Okay, so now here's where change happens. Let's pause for a minute. What is floating around in solution? What can fill in that space? Well, like we saw in the last video, we've got some leaving group. We've got Br minus. What is the one thing that changes in this reaction? Holy crap. What is your solvent? Water. You have 1 trillion of these waters for every one of that Br minus. This is like Las Vegas. Which one are you going to bet on? Are you going to bet on the billions of water with this nice big pair right there and available? We learned in our last unit, water can be a nucleophile, right? And you've got a really good electrophile with a carbocation. Which one is going to fill in that space? Absolutely the water. Okay, so that's our change. And this reaction compared to the last reaction is that now water is going to fill in that space right there. Whereas in the last reaction, he didn't have a solvent that was reactive. This is exactly the second half of the SN1 mechanism from our last unit. We've seen this before. None of this is a surprise. All right, let's put our positive there. Are we done? No, remember we never leave anything charged, so we're not quite done. Now there's two ways we could go with this. We could take our Br minus and react with that hydrogen, or we could take water. Now again, if you're in Vegas and you're a betting person, you got 1 billion waters and your pKa is in your favor if you use water to do that. The only reason sometimes I use Br minus is to show you that HBr is actually a byproduct in this one. In fact, it is catalytic. So let me show that two possible byproducts there. First, let's draw the organic product we're really worried about here. Okay, we just made an alcohol. Not quite booze, but we made rubbing alcohol. All right, then the other, what are our byproducts? Well, we just made HBr in water. What does that look like? Remember, HBr is a strong acid. So what that would really look like is protonated water with a Br minus. This HBr, wait a second, didn't actually end up in our product. So in theory, it helped our reaction. We had to have it right there, but then we reformed it again. This is a catalyst. So in fact, that HBr can be catalytic in this process, and then we will make our alcohol. Okay, I love it. One simple change and we have a totally different product. And now we have this nice alcohol instead. All right, let's do what we did in the last video. Let's just turn right around and repeat this. Only this time, let's repeat it on a ring and look at our stereochemistry. We're going to get the same squiggle line or racemic mixture we got on the last reaction in the last video. This one will also be racemic. All right, let's start this. We have a nice pair of electrons right there out here and available. And then you've got a really strong acid. That is your first step. You're going to reach right out. Nice SN2 there. And then again, we get to swing both ways. So let's evaluate our choices. All right, let's see which one forms the better carbocation. Now we learned, what I love about Unit 4 is not a lot of this is super new. A lot of this we've seen in Unit 2 and Unit 3. We're just combining it. Isn't that fun? All right, let's say we are going to swing down here on that first one. Remember, we get to swing both ways. So let's start there. Let's swing that out here, leaving behind that carbocation. There you go. Then what is the second one? Let's say we swing the other way. Let's put our little green arrow in. Let's say we're swinging up that way. Well, then we're about to form that bond. Oop, we need our methyl. We're about to form the bond to hydrogen here. Leave our carbocation there. All right, you already have the tools in your tool chest for this one. Which one is the better one? Our tertiary carbocation or our secondary carbocation? Tertiary wins. All right, now this one is exactly like the one above it. What is in solution? A teeny amount of Br minus or an absolute quadrillion waters? Pretty sure that's a science term. Water is going to fill in that space. So then what would be this product? Well, again, with this methyl here, this is totally flat. So that means that your water can add in top or bottom. Let's draw both. We are going to add in 50-50 for both of those. That means that will be a racemic mixture. completely racemic. That's our little squiggle line in our product. Now, a lot of times this is implied. So you can even give that, in this case, it's not a stereocenter, but even just writing that normal bond to OH, it's up to you to know that you are going to add 50-50 top and bottom. Okay, then how do we finish this mechanism? Again, we've got to get rid of that charge. What's likely going to take that water? So what are we going to end up making? Here's our product. And then we end up, remember we added our H down here, and we ended up forming that bond right there. Okay, isn't that fun? I love our alkene additions. They're really not too bad. You've seen a lot of this before. It's sort of a new age SN2 and then a new SN1, just combine all in the same mechanism. I kind of love it. If you think about it that way, you've actually already seen all this before. All right, so I'm going to stop this one and post it, and then I'm going to start another one with 2 more reactions. Isn't this fun? Just hold your seats for a second. When I start this next video, I just want you to keep in mind that we are picking up the pace. So in Unit 3, we had 5 reactions for the entire unit. Okay, we should hit 5 or 6 reactions just in our first section of Unit 4. By the time we take the test on Unit 4, we're probably going to be pushing somewhere between 15 and 20 reactions. So we're definitely picking up the pace a little bit. All right, let me stop this video and post it. And